In Lesson 3-1, we're going to be talking about functions. What is a function? What makes something a function? And more importantly, what are domain and range? And why are they important to define a function? So if you haven't done so, please make sure you read and write down the essential question for 3-1. There'll be lots of vocabulary. One of them is a relation. That's a set of ordered pairs. Now, a lot of times in math, we think an XY pair. So I'm going to use an XY coordinate pair, but I'm also going to give it a little bit of a story relation. Maybe we could say 5 t-shirts costs us $15. That would be a relation. Now we could give many relations. Maybe you're going to buy 7 t-shirts or 20 t-shirts. Then we could give you a cost to complete the relation, or in our terms, the coordinate. A function is one in which each input is assigned to exactly one output. So continuing along with my example, I could tell you that 7 t-shirts cost let's say $24. Or maybe I say 9 shirts cost another amount of money. But let's say I told you that 5 shirts cost $22. You have already been told that 5 t-shirts cost $15. This should be somewhat alarming and make you realize that this input for 5 t-shirts had a different output in 2 separate instances. Therefore, this would not make it a function. It'd be important to keep 5 t-shirts always having the same cost. For our domain, it's the set of inputs. In our case, it would have been the t-shirts because it's our X value. Our range is the set of outputs. That's the cost that they might be, and for us, that was cost, but we would represent it with our Y. If we look at other examples, oftentimes they don't have story problems with them. So in this case, we're listed in a table. I'd recommend you use a table, or maybe even more importantly, a mapping situation to help you in the rest of this chapter. So if they ask for the domain, we're just asking for all the inputs, all these X values. And we list our domain with our little funny bracket there, and we just simply list all the numbers that are a part of our inputs. Our range, on the other hand, is all the Y values or all the outputs. We list this in the same fashion. It's important to note, though, you see 13 appearing a few times. That's okay when it comes to outputs, not so much when it comes to inputs. But with the range, we can see that 13 was listed a few times. We don't need to write it that many times, just list the number once. So our domain, in this case here, is all the values in the pink box, and our range is all the values in the blue box, because our inputs are domain and our range is the output. Now back to the idea of a story problem. When you're given a situation, domain and range can be identified for variables. Domain is often your independent variable. That means it's often like time, where time will go on no matter what. So if we look at a bowler paying $2.75 per game, your cost is going to depend on how many games you play. So another thing we should mention is that range is your dependent variable. So I would say the cost is going to depend on how many games I play. So my domain is the games that I choose to play, and the range is the cost. When they ask for a reasonable domain or range, we know you can't play negative games, so my domain for range would be 0 until, you run out of time. Maybe 0 to 20 games. You could decide how many you might play in a session. And your range is the cost. We know you're going to play. If you play 1 game, it's going to cost you $2.75. So your range is $2.75 and up, depending on how many games you play. Another key vocabulary component will be the words continuous and discrete. Continuous just means we include all real numbers, or our function is a nice, smooth picture. So just like the lines you've been graphing, those are continuous. Whereas discrete is more just like a jumble of dots on a grid. Lots of just integers or whole numbers. Little plots, if you will. So you'll want to be able to identify functions as continuous or discrete, and oftentimes it's helpful to plot them. Now, when it comes to deciding domain and range, if there's special relationships, we can call these functions, and we can also call them one-to-one. So when asked about the domain and range and asked if this is a function, these set of points, it may be helpful to list your domain values in one table and your range values in another. Now in this case, none of these values repeat. 1 maps to 2, 5 maps to 6, and so on. Because each of these X inputs only maps to a unique Y output, none of them are repeated at all in either of the boxes, we say this is not only a function, but it's also one-to-one. That means every matchup is unique. Now if we look at B, we see that our domain is all the pink values and our range is all the blue values. No value is repeated in either column. So that's helpful. It helps us know that we could possibly have a function here. But when we look at our 1, it maps to 17, and so does 2. That's still a function. It's okay for your outputs to be repeated. It's just never okay for your inputs to map to different Y values. As in the beginning when we said 5 t-shirts was $15 and then 5 t-shirts was $22. That 5 could never have two different cost outcomes. But in this case, 1 can map to 17 and 2 can map to 17. That's okay. For this one, we would say it's a function because each input only is being mapped to one output. But it is not one-to-one. And that should make sense with our arrows because we can see that both inputs 1 and 2 are sharing the output of 17. Same thing with our 4 and 5, both mapping to 10. That's why these diagrams or bubbles with arrow mappings are super helpful. Our example down here, 2, 3, and 4, nothing is repeated. However, when we look at our 3, it is double mapped. So we would say this is our problem. We cannot have one input mapping to two different outputs. So this one is not a function at all. When it comes to plotting and a line or a graph at all, it's important to check. Does it pass what we call the vertical line test? That is, if I draw vertical lines anywhere along this graph, do I ever cross the orange graph more than once? The answer is no. So that tells us it's a function, because every x value I'm drawing a line at never has two y values with it. Also though, if I can draw a line horizontally and check that my orange line is not hitting it more than once, it is also one-to-one. So to summarize this, every domain must have only one y value that it maps to. That's why this was a no, to be a function. But it is also okay for every domain value to map to something, even if it maps, another domain value maps to it. It's okay to be repeated on the range side, 2 arrows coming into it. It's not okay for 2 arrows to be coming out of a domain value.